My name is Paul Goldsmith from the BURMAD Applications Division. In this video, we're going to talk about commissioning and maintaining a BURMAD pressure reducing station with an emergency shut-off valve. This pressure reducing station is designed to give extra security in the case where there is a possibility of damaging overpressure to the consumer pipeline. To accomplish that objective, the station incorporates two pilot-operated valves. The BURMAD 720 pressure reducing valve set to the required downstream pressure for the consumer line, and the BURMAD 794 emergency shut-off valve set to a higher pressure value but below the maximum allowable level. Under normal conditions, the emergency valve remains fully open. However, it will shut off completely if it senses consumer line pressure higher than its preset value. When the shut-off valve closes, this indicator will move down. At this point, a limit switch will also be activated, which can send a signal to an alarm system or a control panel. This enables quick initiation of a corrective action by the maintenance team. Before we talk about commissioning procedures for this station, I'd like to present its major components. When the upstream isolation valve is opened, water first encounters the main strainer, trapping any debris or foreign objects. The water then enters the primary BURMAD 720 pilot-operated reducing valve. This valve is calibrated using a pilot to reduce the upstream pressure to the design pressure value for the consumer line. The water then passes through the BURMAD 794 pilot-operated emergency shut-off valve. As explained earlier, under normal conditions, this valve is fully open, only entering shut-off when the consumer supply line pressure rises above its preset allowable pressure, which can be adjusted using the pilot. From here, if the downstream isolation valve is opened, the water will go on to the consumer line. Also, in this installation, we have two pressure gauges, upstream and downstream of the emergency and primary valves. Commissioning procedures should be performed when initially opening and operating a station, either for the first time as a new installation or after intrusive system maintenance. Before operating the system for the first time, it is imperative to flush the pipelines. This ensures that the system is free from any debris that can cause damage or even render it inoperable. After flushing, ensure that the main strainer and the valve's control loop filters are clean. Next, observe the station's installation and make sure that all parts are firmly secured and in place. Proceed by verifying that the upstream and downstream isolation valves are closed and that you have typical upstream pressure. Now open the ball valves on the pressure reducing valves control trim. Next, ensure that the service valves on all pressure gauges are open. Note that the pilot levels of the pressure reducing valve and the emergency valve are both set at the factory. You can check the factory pilot levels by reading the label on both pilot covers. Here's the label on the pressure reducing valve, and here's the label on the emergency valve. Before introducing flow to the station, you need to make sure that its preset pressure levels are compatible with your downstream pressure requirements. If this is the case, you're good to go. All that's left to do is to open the upstream and then the downstream isolation valves to fill the consumer pipeline in a controlled manner. Keep monitoring the pressure downstream until flow stabilizes and you reach a pressure that's compatible with your requirements. All right, now let's talk about the other case, which is when the factory set pressure level doesn't meet your requirements and you need to adjust the station's downstream pressure. In this case, all you need to do at this point is to prepare for it. First off, verify that both isolation valves are closed. Now remove the protective cover from the pressure reducing valve's pilot. Release the locking nut screw and completely unscrew counterclockwise the primary reducing valve's pilot adjustment screw until it becomes loose. This allows us to later calibrate the pressure at the outlet of this valve to the required value. Next, remove the protective cover from the emergency shut-off valve's pilot and release the locking nut screw. Then turn clockwise the pilot adjustment screw to the end. Now slowly fully open the upstream isolating valve to fill the station with water. Proceed by partially opening the downstream isolating valve. At this stage, you're ready to calibrate the station's valves. Note that to simulate actual conditions, you should have a typical consumer line open while calibrating, which should get you an average system flow rate. If this is not achievable, then a minimal flow rate will suffice, though not ideal. Also note that at this stage, you should not expect any flow through the station. The reason is that the pressure reducing valve will have closed shortly after introducing water into the station, since earlier we completely unscrewed its pilot's adjustment screw. Now let's start the calibration process of the primary reducing valve and the emergency shutoff valve. We'll begin by calibrating the pressure reducing valve to a value at which you want the emergency shutoff valve to close. Pay attention, we're adjusting the downstream pressure of the reducing valve to the emergency shutoff level. This will enable us later to calibrate the emergency valve itself to the shutoff value. Start by slowly turning the primary valve's pilot adjustment screw clockwise until you feel a resistance and hear the valve opening. At this point, the downstream consumer's pipeline will start to fill. As pressure is introduced to the 794 emergency shutoff valve, it will start to open. Now continue to turn the adjustment screw clockwise to raise the primary valve's downstream pressure until you reach the required shutoff level, which in our case is 5 bar or 75 psi. Now let's turn our attention to the shutoff valve and calibrate it. Slowly turn the emergency shutoff valve's pilot adjustment screw counterclockwise. Bear in mind that when the standard 16 bar spring is being used in the pilot, each complete turn of the adjustment screw will change the set pressure by approximately 2 bar. Continue turning the screw until you see water exiting the vent on the valve's cover. This is normal and signifies that the valve is about to close. There is a tendency to overshoot the calibration at this stage, and the shutoff valve will inadvertently close. If this is the case, then turn back the screw about 2 turns and wait for the shutoff valve to open fully. You can see this by observing the indicator. Then start to close the adjusting screw very slowly until you reach the exact point where the water exits the valve control chamber, but the valve does not start to close. Don't forget to tighten the locking nut and replace the protective cover on the pilot. Now let's get back to the primary reducing valve and reduce its pressure from the current level to the required downstream level. To do that, turn the primary valve's adjustment screw counterclockwise while monitoring the downstream pressure gauge until you reach the required downstream pressure level. In our case, this level is 4 bars or 60 psi. That's it. Finish the calibration process of the primary reducing valve by closing the locking nut and replacing the protective plastic cover. Continue by fully opening the downstream isolation valve. Whether or not you adjusted the pressure levels of the valves, the next step is to remove any residual air from the pressure reducing valve's control loop and chamber. This ensures a more stable and positive pressure control. To vent air from the valve's control loop, loosen the tube eye bolt attached to the valve cover at the highest point of the valve's control chamber. You may notice air exiting the eye bolt. As soon as you get a flow of water without air, retighten the tube fitting eye bolt. Before moving on to maintenance, I'd like to explain a few things about the limit switch and the cam, which are part of the alerting system of this station. The limit switch and the cam are attached to the shutoff valve's main shaft and are both calibrated at the factory. Rarely should they require readjustment. The switch retains its idle circuit connection as long as the pressure level has not reached the emergency level, which means the emergency shutoff valve is fully open. If the emergency pressure level is reached, the emergency valve starts to close, and the limit switch alerts the building management system so responsible authorities can take action. Now let's discuss maintenance procedures for the Burmad pressure reducing station with shutoff valve. Note that your schedule for preventative maintenance depends on actual conditions of use and the station's environment. Here we discuss a schedule suited to a valve operating under average conditions. On a weekly basis, perform a visual inspection of the station and check for leaks and external damage. In addition, observe the unit's pressure gauges to make sure that the pressures upstream and downstream are as they should be. Once a year, close both the upstream and the downstream isolation valves and clean the main strainer and the valve control loop filter. Every 3 to 5 years, inspect the internal condition of the pressure reducing valve. Before we conclude, let's summarize what we covered today. In this video, you learned how to commission and maintain the Burmad PRV pressure reducing station with a shutoff valve. You saw how to prepare the station for first-time use and how to calibrate the downstream pressure and shutoff valve to meet your specific requirements. We at Burmad hope you find this information useful and invite you to contact us with any questions or issues you encounter. Thanks for watching.